All right. Bang. This, and he said, well, if I'm going to take the derivative of the square root of 3x minus 1, I'm going to write it like this first, which I accidentally wrote it to begin with. We know square root bars are evil. And if I were just thinking, well, Mr. Anthony, what do I do with a 1/2 power up there? What do I do with it? Then I just go clunk out in front, then reduce the power by 1. Isn't that the way we normally do it? Put it out in front, reduce the power by 1. Right. So that would be 1/2 3x minus 1 to the negative 1/2. Agreed? Any chance it's the right answer? We look over here and go, is it the right answer? Please be the right answer, because I know how to do that already, right? And so we look at this answer, and it's a little bit weird. But if I look at it closely, it's 3 over 2. This is the negative 1/2 power, right? So it'd be 3x minus 1 to the negative 1/2 power. I am so close. But I'm missing a what?
The 3's.
No, I got the half. Just missing a stinking 3. I'm missing a 3. So close. It could have been so wonderful for us. We could have had that problem done, and we would have been like, but we didn't get it. Let's look back at the one before it, though. And let's use Mr. Cleary's rule. I might be attributing this incorrectly. I thought this is what you were thinking when you said, hey, isn't the 1/2 power, can't I just use that?
Yeah, that's what it is.
Okay, so taking the derivative of this one, using the Cleary rule of laziness and not doing the polynomial like you were taught to do last chapter. All right, laziness is good, right? We're trying to be lazy here. That's the goal. Derivative, you would say it's what? 2x minus 1 to the 1th. Any chance that's the right answer? Let me look at this answer over here. This answer over here is, let me simplify this. This is 4x minus 2 would be your answer. What are you off by? 2. You're missing a 2. Where did the 3 and where did the 2 come from, Miss Wright? I'm missing a 3 that mathematically appeared here. We want to use Cleary's rule, not do the formal definition. Where did the 3 come from?
Is it just from the first?
What would be the derivative of this?
3.
What would be the derivative of the inside of this? 2. Interesting. So, if we use the Cleary rule, do the derivative like we would normally do it, and then we add on the chain, the derivative of the inside, we'd be done. So the official rule ends up looking like this. The derivative of, what's the best way to write this? I'm drawing a blank. Is there something on your sheet? Let me find out a sheet. They probably wrote it good. Oh, no. Oh, no. Let's do it official. Let's do it official. Here we go. Now I know what I'm supposed to do. Here we go. U stands for ugly. What in this problem made it ugly, Mr. Cleary?
You made it ugly.
If this had not had a minus 1 in it, or a 3x in it, wouldn't we be able to do it?
Yeah.
Isn't this thing in the middle the ugly part?
Yeah.
If it just been a square root of x, we've been done. So U stands for ugly. So we're going to set the inside equal to the ugly. So we're going to say, if I want to take the derivative of f, let me set this up, right? Let's go. So steps. Let's do the steps, and I'll go back a step and talk about what we're going to do. So U stands for ugly. For ugly. So you looked at this, you said 3x minus 1. If that was a nice number, nice something, I could do the problem. So I'm going to set U equal to the stuff that's really bugging me. Make sense? Okay? So then I'm going to apply the chain rule. What's a chain rule? I'm going to take the derivative of u. Let me write that up as a definition. Derivative of u with respect to... No, I'm not. I'm going to take the derivative of the function of u. Let's write it that way. With respect to u times the derivative of u with respect to x. That's the way I should write it. I'm trying to be very careful here. I'm avoiding all sorts of things. I'm going to take the derivative of the function with respect to u times the derivative of u itself with respect to x. Notice how these would cancel out. So I take the derivative of the function with respect to x, ultimately. I'm just taking a step in between. So, here we go. Here we go. You ready? So applying the chain rule. Here we go. We're going to take the derivative with respect to u of this with the u already in there. So that'd be u to the 1/2. We're going to take the derivative of u to the 1/2. Okay, I'm stopping here. Hold on. Okay, so I'm replacing the square, what's inside the square root bar with u, right? Then I'm going to take times the derivative with respect to x of u itself.
Wait, so the ugly is the entire thing under the
U is just this. Yes, the entire thing underneath the thing. I define what is bugging me. I look at the problem and go, that is the part that's making my life awful. And I call it ugly. And I say U is equal to that. I say U is ugly. Then, moving it forward, here we go. 1/2 u to the negative 1/2 times the derivative of the inside, which would be what? 3, right? So then this becomes 1/2. Now I put the u back in. What's u? 3x minus 1. Right? So the negative 1/2 power times 3, and I'm done. 3/2, 3x minus 1 to the negative 1/2 power. Chain.
So you're telling me.
So your first step is going to define what makes the problem ugly. What is making it so you can't just do what we've been doing?
And this only applies to square root bars, right?
It applies to all sorts of things. Let me show you. What if I gave you sine y equals sine t squared?
Can't do that.
Can't do that because the t squared is in there with a sine. So unless you know a lot more trig than I know you know, you're stuck.
Yes.
Except I can do the chain rule. What's making this problem ugly for me?
The t squared.
The t squared. So let me scroll this forward one page.
Why would you use t? Just use x.
Okay. We're going to do a sine x squared. My apologies. So now look at this go, what's making it ugly is x squared. Agreed?
Yes.
So I'm going to take the derivative with respect to u of sine u, putting the u back in, but replacing out my x, getting it out of there. Get the ugly part out. Times the derivative of, with respect to x, of x squared.
So, we take the derivative of x squared.
Derivative of x squared is just 2x.
Plug that back.
Oh, no, hold on. What's sine of u? What's the derivative of sine of u?
Cosine.
Cosine u, right?
So you just take the derivative of both.
No, yes. So you take the derivative, well, we'll talk about that in a moment. But this is the way, I want you to see the formula, I want you to use it for a little bit.
You take out the ugly part, and then you take the derivative of the ugly part, and then you solve out the ugly part, and then you put the ugly part back in and solve it.
Sort of, yes. It makes me nervous to say that, but yes.
Okay.
Okay, so then the cosine would be, so I put u back in, x squared, I'd probably throw the 2x out front to make it look pretty.
Oh, see, that's the problem. Why would you plug u back in?
Because that is cosine u. It is actually still u.
You should take this.
I'm temporarily saying I don't want to deal with x squared. So I'll make it u, and then I'll tack on this derivative chunk on the end.
So then what happens to, why did you put the 2x in front then? What happens to the 2x?
The 2x is right here. I just moved it out in front because I don't want it behind there.
Multiply.
Yeah. They're two are multiplied together when you're done. Chains are multiplied.
So, okay.
Okay?
Why is that x squared? Okay. I understand.
Well, because I started with sine x squared. So let's do the next problem. Flip it over down the back. Take a look at the very first problem. I got f of x equals negative 3x plus 1 to the 4/3 power. Try that one out.